Hello guys, welcome to another video. In this video, we will see what is table API and how can we use table API in Apache Flink. So table API in Apache Flink is a high level abstraction for processing structured and semi-structured data. It provides a declarative syntax similar to SQL for defining data transformation. So on high level, it's like an API or an high level interface with which we can transform the data. The data can be of structured or semi-structured data. What is the main advantage is we can leverage the SQL in the table API. It's similar to SQL. We can even write all the transformations in SQL as well. So that's the major advantage of table API. The table API is a unified interface for stream and batch processing both. It operates on tables, so we create the tables with the source data and we transform the data using the table API methods, or we can use SQL as well. So what are the key features of table API? Declarative syntax combines SQL-like semantics with programmatic API. Unified processing works both for bounded and unbounded data. Bounded in the means like it's a batch data, a set of records in specific time period. Records till specific time range is called bounded. Unbounded means a continuous flow of records. There won't be any end to the data. That's called unbounded data. Seamless transition. We can convert the table API into data stream API. In the next tutorial, I'll explain what is data stream API. So there are multiple built-in operations with which we can do aggregations, joins, windowing, filtering, and transformations, which we are going to see. So here I just import all the required libraries, and now to use a table API we have to create an environment first. Like in Spark, how we create a Spark session and everything will started with the Spark session, right? Similarly here we have to create an environment. So how do we create an environment here? So we have a class called environment setting dot in batch mode if you are using the batch mode. If it's a streaming, then in streaming mode. That's it. So we created environment settings and we have to pass that inside table environment dot create of environment setting. So everything starts with this variable table env now. If you see, I have a very basic example here. Table env dot execute SQL. What I am doing here is I am creating a table with connector of data gen. So if you use connector equal to data gen, the data is generated automatically. So it's just kind of a module from Flink to generate the random data. We can think of like that. So connector equal data gen. If you have Kafka here, we will use Kafka. If you have files in which we need to read, we use file system here, like that. So here this is just an example to show how the table looks, which we create using the table environment variable. And if you see, we have even said the kind of data in the ID column should be sequence. It should start with 1, it should end with 30, number of rows should be 30. So now we just had the create table statement, so we can create a table out of it. And now table env dot from path of data gen, this is a table name we have to pass, so we'll have the table. So the source table dot execute dot print. So how we do dot show in Spark, here we use dot execute dot print here. So if you see, it has generated the data. It's not in order. If you do order by, it will get in order. The first one is of type ID, it generated the integers, and the second one is of type string, so it generated the string data. So now let's go and see the very real-time example. So we can even create a table using the table API in Apache Flink with the list of elements as well. So here if you see, I have a list of 1 Praveen, 2 Reddy, C 3 Chinna, with these 3 which are in a list, and with that list also I can create. So the table env is what we have created here, like a Spark session in Spark. So we have to first create the environment settings and pass that environment settings to the table environment class. That's it. So table env dot from elements. With this also we can create a table. So this is how our table is. And we can even pass this schema as well. Here we don't have the header, right? We can even pass this header as well. If you see, I just pass the same list, comma, the schema. Data types dot row of, data types dot field of ID, and what is the data type? Data types dot field of name, what is the data type? All this. So like this we can even create the tables. So table dot execute dot print. So it just print with the schema or with the header, we can say. That's it. So what if you have a pandas data frame and if you want to create the table using that pandas data frame, we can do that as well. So this is a pandas data frame. df.head, I got the pandas data frame here, and table env dot from pandas or pass the data frame. That's it. I got the same data here as above. So now we can create the tables even with the file somewhere in some path. So we can even do that. So here what I am doing is table env dot execute SQL, and I am creating a table saying the connector equal to file system and the path and the file format. That's it. So I have this file input1.csv. That's it. and now I'm able to create the table. So just we have to give the DDL here, and then table env dot from path of that CSV table name, CSV table dot execute dot print will load this. That's it. So now once you create the table, you can do any kind of transformation using the SQL here. So table env dot SQL, here I am just using the CSV table. So we do have the CSV table which we created above, right, where ID greater than 2 or equal to 2. So it just printed 2 and 3 alone. So we can just use the plain SQL and do all kind of transformations, joinings, everything. Any kind of SQL can be written inside this. That's it. And now all the tables which we created using this table env, it can be viewed as well. If you see the table env dot get current catalog, and also Apache Flink stores the tables inside the catalog database and the tables inside that. So there will be catalog on high level, and there will be multiple databases next, and for a specific database we'll have the tables. You can even decide the database as well. So while creating here, you can mention the catalog dot database dot table name. So if you see, I just got the current catalog it is using, which is using the default. If you don't mention it, it creates everything inside the default catalog and the default database. Get current database as return the default database, dot list tables return the list of tables inside the database. And if you have very temporary tables we create also, we can even list them as well. So everything can be viewed. So now I have an employee data here. All this is an employee data, and I have a departments data, and I have orders data. So I'll just create the tables using those. So first let's create employee and department. If you see, I just created an employee with connector file system, path, the path where I have the file, and the type CSV. That's it. Table env dot from path of the table name which we have created. That's it. So this employee table will be the table now. Similarly, I created one for the department table. So if you see, so employee table dot select of, I just selected the required columns. To select the required columns, we have to use call of the column name. That's it. So it printed those. To print it, dot execute dot print. That's it. And in case if you want to select all the columns, you can use call of star as well. In case if you want to rename the specific columns while selecting, you can even use dot alias as well. So the employee table dot alias, the employee ID has been replaced with the ID. Department ID has been replaced with the dep ID, like that. You can even change by using this method called alias. And in case if you want to apply any filter condition, you can even do that as well. So employee table dot where call of age greater than or equal to 30, only the age greater than 30 records have been filtered out. And in case if you want to add a column in Spark, we use df dot with column, right? You can use this employee table dot add column, and the logic which we need to add here, and the name should be, the column name should be name underscore age, and the logic here is the concatenation of two columns. One is of type int, so I'm just casting it so that we can concat. Int and string can't be concatenated, right? So both should be strings. So I just concatenated here. So John 29, like that. And in case if you want to add or replace, in case if the column does not exist, add it. If it exists, then replace it. You can use add or replace. So similarly, the logic, and after dot alias, we'll have the column name. In case if you want to drop a specific column, the table dot drop column of columns. That's it. So in case if you want to rename a specific column, you can just reuse this particular method as well. Dot rename columns of call of employee ID. I want to replace the employee ID column with ID. That's it. So it is replaced. And in case if you want to do some group by and all, you can do it, like employee table dot group by of on what column you want to group by age, and then here you have to select the first group by column, and then the aggregation operation you want to apply. So the call of salary dot sum. So after summing, just name the column name as salary by age. That's it. That's what we got here. Similarly, you can apply all the aggregation operations which we can do after group by. And now here I'm just creating another table from the path. That's it. The table name is orders table, and the purpose of reading this particular specific table again is to show you how we can do the windowing operations, because the orders table has a column called timestamp. So let's assume this particular file gets loaded continuously, the data gets appended continuously. Then let's see how we can do some operations using windowing. So windows are a core concepts of grouping unbounded data stream into bounded logical chunks of data. So what it says is, when you have unbounded data or a continuous stream of data, and to group them into a bounded chunks, then windowing is a crucial thing, because we can window based on time, we can window based on number of rows and all those things. So here on a high level, they have divided into three particular windows, and the session windows is not supported. We have only tumbling window and sliding window. So What is tumbling window? Separating first 10 as one window and separating the second 10 as another window is called tumbling window. And how can we separate the first 10 and second 10 separately? Either you can use based on the rows, number of rows, or you can use based on the time. So if we have the continuous time here, right? So this record is generated every 5 seconds. So what if you use a 20-second window? So the first 10 records will go into one window and the second 10 records will go into another window. Like that we can even separate. And the second one is tumbling window. In the tumbling window, there will be an overlap between the windows. I've told you that in tumbling window, there will be a specific separation of records, right? There won't be any overlap. So this record will be only in the first row. So as we have separated till 10 records, the 10th row will be only in the first window. It won't be in the second window. But if you go with the slide window concept, where if you see, the visitor IDs gets generated every 2 or 3 minutes, right? So if you see in the slide window, we have to mention the window size and the slide interval as well. If you see, the window size is 10 minutes and the slide interval is 5 minutes. So for suppose, let's assume our job has started at 9 o'clock. So the window size will be 9 to 9:10. And we have mentioned the interval as 5, right? So it starts 5 minutes before and then 9:15. And again 5 minutes before, it starts from 9:10 to 9:20. And the next window will be from 9:15 to 9:25. Like that. So now if you see, we have the table, orders table, which we created. So the data gets loaded into this table continuously if it's a streaming, and if it's a batch, it loads when we load it. And now first we are creating a window here. And how we are creating window, as it's a tumbling window, tumble dot over of 15 minutes. So we segregated based on the time. For every 15 minutes, create a tumble window. On which column I need to create? So it has to need one date time column, right? Or timestamp column, right? So on ordered time column. And this ordered time column will be there in our orders table. So it just creates the window for every 15 minutes. And in that window, you can apply any kind of operations. If you see, I am grouping on product and that window on order time. If I don't use order time, the purpose of window is no use here. So I am using, so for every 15 minutes, I am getting the product and the sum of sales for that product. So here if you see, I am grouping based on the product and order time, and I am selecting first the grouped column and then the column which I want to do aggregation, call of price dot sum, and I am just renaming that. So it has grouped based on the window, the time window, and on the product, and we got the sum. Similarly, if you see the slide window, as I said, there will be overlap, right? So the records will be in both the windows. The records which came at the end of the window will be in the first window as well as in the second window. So here if you see, the syntax is overall the same, but it has one extra thing called dot every, and this is the overlap time we need to mention here. That's it. And the session window is not supported, so it threw an error. And to get distinct records in a table, you can just use the table dot distinct dot. You can just use the table dot distinct. That's it. And in case if you want to rename the column, you can use dot rename column, the old column name, dot alias the new column name. And in case if you want to join two tables, here we have joined employee table and department table. On inner join I want to do. So dot where on the columns, these two columns. That's it. And you similarly can do left outer join, right outer join, and everything. So the table name dot left outer join, the other table name, and now here the joining condition. That's it. So it is a left outer join. Similarly, you can do the right outer join and all those things. And now not only the joining of two tables, we can even join the table and the UDF as well, which I tried here, but somehow I am not sure why I got an error. But I have another example down which I'll show you on how to join the table and the UDF output both. Now in case if you want to do union all on two tables, you can do department.union and again. So I got the same data twice. Union, so duplicates will not be there, so only one data. And intersect all will be there. So minus, so when you do minus, records which doesn't exist in the second set will come from the first, right? So there are the only same, I did on the same table, so you got empty set here. So in case if you want to use in operator in the where, you can even use. So first what I have done is, from the department I have just selected the list of department IDs, that's it. And I am using those IDs to filter out the departments from the employee table. So employee table dot where of call of department ID dot in this department IDs, that's it. So you can even do order by, employee table dot order by on which column you need to order, whether it's a descending or ascending order, dot execute dot print to print it. And we have another method called offset. In case if you don't want a first set of 5 records or 10 records, you can use dot offset of 3. In case if you want to skip the header or something like that, you can use dot offset of 1. The first row will be skipped. I use offset of 3, so the first 3 rows got skipped. So now we have seen the windowing, the sliding and the tumble window before, and we have done the group by and aggregation operation over there. So there can be scenarios where we have to use windowing, but you don't have to do any group by operation. Without group by operation also we have to handle some scenarios, like, right? So that can be handled as well. We can apply windowing both for unbound and bounded. Unbound means the streaming data and bounded means the batch data. See, if you see unbounded means include all rows from start to the current row. Bounded means includes a finite range of rows related to current row. So I just created orders table final, that's it, and I'm using that table. And here if you see, I'm just partitioning on product and ordering on the timestamp column dot partition unbound range. That means the whole data will be in a single partition only. I don't want to partition based on specific rows or specific time period here. And find out the product in the whole data is what I meant here. There should not be any specific window on some time range or some row range, number of rows range. That's it. And here if you see, I'm selecting the product, order ID, call of price dot sum. So now if you see, it partitioned on product named product 2. If we go to the orders table, we have the product 2, 3 rows, right? So it partitioned on this. And now if you go to the orders data, you have 120, 130, 40. So I'm just calculating the sum of the price. So the first row will be 120 and second should be sum of 120 plus 130 and third should be sum of 120, 130, 140, 3. So that's what the output we have got here, 390, the sum of the 3. That's it. So here it's an unbounded run. So I didn't again window based on specific time period or number of rows. So it's just an unbounded run. So you can use unbounded range or unbounded row completely. Here if you see, I partitioned on product, order by and ordered time column, which is a timestamp column from the source file. And again I am partitioning for every 10 minutes. Okay. And in the 10 minutes, I am just calculating the sum of the price. That's it. That's it. That's what happened here. That's it. Now, not only on a time range, you can even partition on number of rows as well. If you see here, inside preceding here, I sent rows interval of 2. Rows interval of 2. So, what I am saying is, partition on product first and then sum every 2 rows here. So, now if we go here, we have a product 1. See 100, 110 and after that 150, right? So, now if you see product 1, so first is 100 which is fine. And second should be sum of 2 rows, 100 plus 110. So it is 210, which is very much fine. And now, and the second is 360. What is this 360 means? 210 plus what is the value here? 210. See, this is I mean, we already calculated 210. 210 will become 1 row and plus this 150, which will be 360. Like that. So if you are seeing here, it partitioned on product and again sub partitioning for every 2 rows. And calculating the sum. That's it. So this is also another way to calculate or to partition the data first based on some column and again sub partition based on the number of rows. That's it. Now if you see, I just created a UDF here. That's it. And what that UDF does is it just multiplies 2 to the value which it gets. That is nothing but the column price. So I'm just selecting all the columns and I'm just applying that UDF here to one of the column. Double price, this method name, UDF name, column of price, and alias it with the new column name. That's it. So if you see double price, it has become the old original price was 100 into 2, 110 into 2, like that. Now we have another methods called map and flat map as well. To apply a transformation on each row, we use map and to apply transformation or to make multiple rows from a single row, we use flat map. Similar to what we do in Apache Spark, the same concept here. So here I first created the method here, that's it. What this method takes is, it takes a row, complete row as input and it creates another row and it has 2 columns. The first column is the price into 0.1 and the second column is price minus price into 0.1. So what is the discounted price and after discounting what is the actual price for which we get that specific product is what this particular function does. And now I'm just binding it inside an UDF and I'm just saying these are the return types from this method. Now if you see order table dot map of, if I pass this function, and what should be the column names for these two, the one should be discounted value, to pay after discount. That's it. So the first one is might be 100 and the discounted value is 10 rupees, and after discount you have to pay 90 rupees, like that. So we can apply map something like this to apply some transformation on each row. Similarly, you can do the flat map as well. Here I am just creating the data. So from the list, if you want to create a table, we know, right? The table env.from elements, pass the list and the schema name. That's it. So I just got the data and I'm just splitting those on hyphen, and I'm just returning those, the first and the second element. That's it. From a single column, we create the multiple columns using flat map. While joining the table and the UDF, I was getting an error, right? Like while concatenating the data of the table and then the UDF, I got an error, which is what I showed you above. But I just got it again. I tried it. Here, if you see that this data is a table, join literal of the UDF, and the UDF output we are just aliasing with the column names A and B. And this is a UDF method. MTHD is a UDF, and what this that is, it just splits it. That's it. If you see here, so I got the actual data and the UDF output as a separate columns again. So we can even join the table and the UDFs as well. That's what I'm trying to say here. That's it. And these are all the data types which we have, the respective data types in Python and pandas. Small, big, int, float, double, varchar, decimal, timestamp, and all these things. Macro. That's it. So this is what an high level on what is table API and what is table and what kind of transformations we can do on table in Apache Flink. My next video will be on the data streams API. Thank you so much for watching.